All right, well, welcome to Lesson 5.4, and tonight we're going to be talking about multiplying and dividing fractions. And actually, after adding and subtracting fractions, multiplying and dividing, even if they're mixed numbers, is actually going to be easier. Yep. And as usual, I've got my trusty fellow Ben here to help me today. So let's get started right into this, Ben, and let's just go ahead and just practice some problems. So let's first start with multiplying. Yeah, my stylus isn't working. Multiplying. There we go. All right, and so let's start with 2/5 times 1/3. And the nice thing about multiplying fractions is basically all we do is multiply the tops and multiply the bottoms. Unlike in fractions where when we added and subtracted them, when we had to get common denominators, here all we got to do is multiply across, right? 2 times 1 is 2, and 5 times 3 is 15. Make sure nothing cancels. If nothing cancels, we circle it, and we are done. All right, let's try another one. Let's throw in a negative this time. Let's do negative 5/6, and let's multiply that times 2/3. Okay. Now, a couple things a little bit different on this one. Before we multiply this one, there is a rule with anything on the top, either the 5 or the 2, can cancel with anything on the bottom. And so in this case, if you look closely, you see a 2 and a 6. They're both even, aren't they?
Yeah.
So I can take a 2 out of both of them, because ultimately what I'm going to really do over here is I'm really going to get negative 5 times 2 on the top, and I'm going to get 6 times 3 on the bottom. Well, if all of this is going to end up in one fraction together anyway, might as well go ahead and take out common factors before I do the multiplication. So if I do that, I've already taken a 2 out of both of these. So on the top I get negative 5 times 1, which is negative 5. And on the bottom I get 3 times 3, which is 9. And I'm already done. So you can skip this step right here in the middle. Okay? Absolutely completely. Like this one right here. We don't have to do any of that. We can go right from these circles over here and cancel the 2 and the 6 and immediately change to the final answer. Okay? All right, let's try another one. Let's try 7/8 times 5/9. All right, do you see anything that cancels on this one? So again, look at the top and the bottom. Unfortunately, I don't see anything, so this one is going to be 35 on the top, and what on the bottom?
72. Yep,
72. And if we do our work correctly, and we double check very carefully that nothing over here canceled, then this will already be in simplest form.
And
we'll
if you look at the answer, you could maybe figure out if you saw it, you could reduce.
Yeah, if you miss something that should have reduced, and you end up with like an even number over an even number, then you can go back and you can fix it. But you shouldn't have to. But it is a good way to catch your error. All right, let's squeeze one more of these. We've got a little bit of room down here in the corner. Let's do a double negative. Let's do negative 1/4, and let's multiply that times negative 3/8. Okay, and in this one, we're going to use all those tricks that we've learned all year. So what is a negative times a negative going to equal?
Positive.
Right, it's going to equal positive. And so negative times negative, 1 times 3 is 3, and on the bottom, 4 times 8 is 32. And that is the answer without any negative signs, okay, because they canceled out. So that is multiplying fractions. Okay, let's continue with the simplifying. Why don't we give them 3 problems to work on?
I mean, if you see how easy it is,
yeah,
it won't take that much.
I tend to agree. All right, let's jot 3 problems down here. Hold on just a second. Okay, so here's 3 practice problems, and what all of these are going to do really nicely is there's going to be a lot of canceling, and also you notice in the third one we introduced a variable, and variables can be part of the fraction, so don't let that stress you out. Okay, so go ahead and pause the video, please, and right now on your notes or on a scrap of paper, go ahead and just write down these 3 product multiplication problems, and simplify them as much as you can before you multiply, and then come back and check your answers and see if you get what we get. Okay? So go ahead and pause the video now. All right, welcome back. Let's dig right into this. On the top, I think you noticed that 6 and 3 are both divisible by 3, so this should be 1 and 2. So what do I end up with?
4 And
over 7, and that is the final answer. On the next one, I have one negative, so before I even forget about that, let's go ahead and put the negative in. All right, I got all kinds of stuff that can cancel. The 5 could cancel with either the 15 or the 25. I'm going to choose to cancel with the 25. I'm going to preserve the negative, so I'm going to take a 5 out of that. I get -1. Down here, I'm going to get 5.
Works.
And then for the 15 and the 21, I'm going to take, what out? What can you take out of that? Not a 5, but what goes into 15 and
3.
21? Right. And take a 3 out, you get 7. And you're going to get, take a 3 out, you're going to get a 5 here.
Yeah.
And you look for anything else that cancels, and there isn't, so it's -7 on the top. 5 times 5 is 25 on the bottom, and sure enough, we've taken everything out, so we are done. And the bottom one, what can cancel on that one? Well, 3 and 9 are both divisible by
3.
Take a 3 out, you get 1 and 3. And the 2 and the 4 are also both divisible by something.
2.
Take a 2 out, you get 1 and 2. Now be careful, we still have the x. So I'm going to go ahead and circle that, or you could have written, I could have crossed out the 2x and just wrote down x when I took the 2 out. And so what I'm left with on the top is 1 times x times 1, which is just x. And on the bottom I have 3 times 2,
6.
which is 6. So the big difference here, really two big differences. One is we're going to multiply across the tops and multiply across the bottoms, whereas when we added fractions, we only messed around with the tops. Once we got the fractions to have the same denominator, we didn't do anything with the bottom. So here we are going to actually be multiplying the bottom as well, plus we have all this cool canceling that can happen. All right, well, next up, we have mixed numbers. Now, mixed numbers, there's 2 ways to multiply them. So suppose that we're multiplying 3 and 3/4, and we're going to multiply that times 2/5. The way that I recommend people do it is to change the mixed number into an improper fraction. All right, so if we rewrite this problem, that first one, 3 times 4 is 12, plus 3, it's going to become 15 over 4. And the second fraction is already a fraction, so we'll leave it as 2/5. Well, look, I see stuff that's going to cancel. The
Yay.
15 and the 5 are both divisible by 5. If I take it out, I get a 3 and a 1. And the 2 and the 4 are both even, which means they're divisible by 2. Take it out, you get 1 and 2. And on top, we'll get 3 times 1 is 3 over 2. And I should really simplify that back to 1 and a half. And there we go. Now, let's take this same problem, and let me just show you the other way to do it. And the other way to do it is going to look kind of like the distributive property. If you break 3 and 3/4 up into a whole number and a fraction, and we multiply that by 2/5, if you remember back to the distributive property, remember how we used to take the thing that was outside and we'd multiply it by both of the things inside?
Yes.
Well, that's what we're going to have to do. So the 3 will become 3 over 1, okay? And we're going to multiply that times 2/5. And then we're going to add that to 3/4 times 2/5. All I've done here is I've taken this 2/5 and I've multiplied it by both the 3 and the 3/4. Now, each of these is a separate multiplication problem. I don't see anything that reduces in the first one, so that's just going to be 6 over 5. Agreed? Okay, now in the second one it's a little harder because the 4 and the 2 will reduce.
Cancel.
Take a 2 out, right? And so I get 3 times 1 on the top and 2 times 5 on the bottom, which is 10. But now I can't actually add these because I need a like denominator. So what I'm going to do is I'm going to actually cross this out, and I'm going to rewrite it over here where I change 6/5
It works.
into something over 10, and that'll be 12 over 10. So I get 15 over 10, which reduces down to 3 over 2 if I take a 5 out, which reduces to 1 and 1/2.
Yes.
And ultimately, I do end up with the same answer I got up here, but it wasn't quite as easy. Now, there will be some problems that it will be easier to do the second method on. There will be many more problems where the top method, changing the mixed number,
Might want to highlight that.
yep, changing the mixed number.
Yellow. Ugh, it's a weird looking color.
How's that?
That's better.
All right. Oh, but we have a yellow screen. That was probably not a good idea. All right. So there'll be many times where changing the mixed number into an improper fraction
That's very large.
will be easier. There'll be other examples where this will be easier. Now, there is a catch to this, Ben. And the catch is, suppose you have 2 mixed numbers. if you have two mixed numbers like 3 and a half, and you're multiplying times another mixed number like 2 and 2/3, well, then it gets more complicated because you actually have to break both of them up. So the 3 and a half will break into 3 plus a half.
Yeah.
Okay?
Man, it's not working.
I know. And the 2 and 2/3 will break into 2 plus 2/3. And what you have to do now is you have to do all the possible combinations. So you have to multiply the first times the first, the inside one times the other inside one, the outside one times the other outside one, and the last one and the last one. So you have to do all four combinations. Now, this isn't the end of the world because this is my friend Harold. If you look at it closely, Yep, Harold, if you look at him closely, here's his mouth.
Eugene.
Okay? And then he's got this weird kind of hairdo. If you look at these things up here, those are kind of a weird hair. And then he's got this big chin down here at the bottom. So this is my friend Harold. Another idea is FOIL. Other people remember this by FOIL. The first stands for, F stands for first. O stands for outers, that's the green one. I would be the mouth, that's the inners. And L would be the last, that would be the 1/2 times 2/3. So if I go through and I do all these, the first 3 times 2 is 6. Okay? The outer 3 times 2/3 is actually, think of 3 as 3 over 1. So that'll be, it'll either be 6 over 3, which then reduces to 2, or you can cancel the 3's and you'll get plus 2. The inners is 2 times a half, which is plus 1. Half of 2 is 1. And finally, a half of 2/3, if you multiply those, 1/2 times 2/3, the 2's cancel and you get 1/3. And if you add all this up, you get 9 and 1/3. Of course, if I do it the other way, let's take the original problem. If I just change them into improper fractions, 3 1/2 is 7 over 2. 2 and 2/3 is 6/8 over 3. Okay, the 2 and the 8 cancel and become 4 and 1, and I get 28 over 3. 3 goes into 28 9 times with a remainder of 1.
No, it doesn't.
9 times 3 is 27. So you get a remainder of 1. And sure enough, I get the exact same answer. So you could argue sometimes the improper fraction way is better, and sometimes doing all this foiling stuff is better. Generally speaking, if the mixed numbers are fairly large, like if you have things like 14 and 7/9 times 21 and 11/13, changing them into improper fractions makes them really big. So that's the one time where kind of seeing this foiling is a good way to do it. But that's actually something that we're going to do later on in algebra next year. So it's really just good to see that. I would recommend doing it with the improper fractions. Okay, why don't we do one of those for practice? Oh, no, let's make it 2. All right, so we're going to give you 2 more practice problems, bringing the total number of practice problems to 5. So go ahead and, and let's give you a couple problems here. All right, so try these 2 practice problems here. 2/3 times 1 and 2/7 for the top one. And then also number 5, do 3 3/4 times 2/5. And I would recommend doing these using improper fractions. So pause the video, do the problems, and then please resume. All right, welcome back. So what you need to do for both of these problems is you need to change the mixed number to an improper fraction. So the first one is going to be 9 over 7. And the second problem, let's go ahead and just do this right now, Ben. 3 times 4 is 12, plus 3 is 15 over 4. All right? Now, look for stuff that cancels. I see a couple things. On the top one, the 3 and the 9 cancel by taking a 3 out, so this becomes 1, and this will be left with 3.
That's the 3.
There we go. That's kind of a 3. All right, and I think that's it. So let's go ahead and multiply across the top. 2 times 3 is 6. 1 times 7 is 7, so we get 6 7s. That is the answer you should have gotten. All right. On the bottom one, again, we can cancel. The 15 and the 5 are both going to cancel. They're divisible by 5. So this will become a 1, and this will become a 3. Okay, on the other diagonal, we have a 2 and a 4 that are both even. So I can take a 2 out, and I get 1 and 2, and so I'm going to end up with 3 times 1 over 2 times 1, which is 1 and 1/2 if I change it back into a mixed number. Okay, so that's it. That's multiplying fractions, which brings us to one last topic, dividing fractions.
Oh.
Almost forgot about these. So when we're dividing fractions, all we're going to do is we're going to flip and multiply. And it's very important that we flip the right fraction. It's always the one that was being divided that gets flipped. And when we do that, we also change the divide sign to a times sign. So this first 3/7 will stay the same, and the 1 over 5 will switch to 5 over 1. And now we multiply just like we just did. So 3 times 5 is 15, 7 times 1 is 7, and if I simplify that, 7 goes into 15 twice, with a remainder of 1. Okay, so that is how we divide fractions and or mixed numbers. All right, let's do another example. Let's do 1 and 1/3, and let's divide it by 5/6. Okay, so obviously if you just think about this in practical terms, 5/6 ought to go into 1 and 1/3 a couple of times. Well, this combines both of the things we just talked about. 1 and 1/3 is going to first have to become an improper fraction, which is 4/3. The divide is going to become a times, and the 5/6 is going to, because it was being divided, is going to flip upside down. We look for a little bit of canceling, and I see just a little bit that can be done. I see both 3 and 6 are divisible by 3, and if I take it out, I get 1 and 2. Now 4 and 2 are both even, but the problem is I can't cancel those because they're both on the top. You can only cancel something on the top with something on the bottom. You can never, ever cancel side to side. What we can do at this point is we can multiply across the tops. 4 times 2 is 8, and 1 times 5 is 5, and 5 goes into 8 one time with a remainder of 3, so I get 1 and 3/5. So that is how we divide fractions and mixed numbers. And we will practice, obviously, both of these skills in class tomorrow. But that concludes 5-4. So this is Mr. Gunn and Ben saying thanks for watching our video, and we'll see you in class tomorrow.
Good night.